So let's say they give you a function of g of x and they say it's defined as absolute x minus 3. And they ask you to please determine the derivative of this function from first principles. Okay? Or in fact, they'll say using the definition of the derivative. That's how they say it. So here we tell them that we are looking for the derivative at any point, right? So we say it's going to be the limit as h approaches 0, but it's the limit of g of x plus h, which means where we see x, we replace it with x plus h, and then we say minus 3. Well, maybe it's nice if we begin by using a formula. How's that? Yeah, let's just say that and say we have g of x plus h here and minus g of x, right? And divide this by h. Yeah, let's say that. Then, of course, this is just going to be the limit as h approaches 0 of absolute x plus h minus 3. And then we say minus absolute x minus 3 like that. And then we say this entire thing is simply divided by h. That's fine. Now the question is, where to from this point? Because if we use direct substitution, we are simply going to find that our h will be 0. Yes, that's true. But then the numerator will also be 0. So we have a 0 over 0 case. And the question is, which algebraic manipulation are we going to perform in this case? So what I want you to realize in this case is we can't really factorize. We can't expand. Well, we really can't do much to this expression. So which is why here we need to reverse what we know. Now, what do I mean by that? We know that every time we see the square root of x squared, we actually see absolute x. So what we need to do here is to reverse this and say, where we see this, we actually see the square root of that. Okay? So in other words, for the first term in the numerator, we actually see x plus h minus 3, and this is all squared. So in the place of x, we put x plus h minus 3. Then we come back to the next one and say in the place of x minus 3, we put x minus 3 all squared under the square root as well. And then we say this entire thing is divided by h. Now we still have a 0 over 0 case. The question is, how do we get out of this mess? Well, the easiest way out is to actually rationalize our numerator. So of course we know that when we rationalize, we multiply this expression by 1. But we define our 1 as the conjugate of the numerator divided by itself. So this is what we are simply going to say. And we know that if we must multiply two conjugates of one another, we don't need to use the FOIL method, no. We can just multiply the first terms together and the last terms together, because we understand that the middle terms will cancel out. Think of it. What is the expansion of x plus 1, x minus 1? Well, it's x squared minus 1. We only multiply the first terms and the last terms together, because the middle terms were negative x plus x, and they committed suicide. Okay. Now moving on, if we multiply those first two, we get x plus x, in fact h, minus 3, which is squared. And here we get x minus 3, which is all squared. Then we say, what is this divided by? We also know that when rationalizing the numerator, we keep the denominator in its vectored form, which means we don't distribute the h. We just keep the h there. And here we simply have x plus h minus 3, which is all squared. And here we have square root x minus 3 squared as well. And this is what we have. Then, of course, here we need to expand this, unfortunately, because if we still use direct substitution, we still get a 0 over 0 case. So the question is, how can we expand this? Hey, it's a little bit of work, but let's go through it. Or we can choose to expand it in a rather intelligent way and say, instead of us having 3 terms that must be multiplied together, we can just say, well, let's take x minus 3 and put it together, and then we say we have h. Then this makes us to have only 2 terms instead of 3, right? And it's now easy because it's the same expansion as that one. So what is it going to be then if that's the case? Well, it's just going to be x minus 3 squared. Then you say x minus 3 times h. Now I think we should write it here. So we have the limit as h approaches 0 of x minus 3 squared. And then we have x minus 3 times h multiplied by x minus 3. Collecting the like terms, we have 2h into x minus 3. And then we have h squared there. And we still have x minus 3 squared. Do you see where this one comes from, the middle one? It's because we are going to have x minus 3 times h, and then we have h multiplied by x minus 3. And since they are like terms, it's like we have a 1 here and a 1 there, so we just add them up, we get 2h into x minus 3. Then we say this denominator is just going to be h into square root x plus h minus 3. And then you say this is squared. And then you say plus. You have the square root of x minus 3 squared. And then you close the bracket there. Okay. Now, if we look at the numerator, we can see that this one as well as that one, do you see we expanded it in a very intelligent way? So they will simply cancel out. And now we have the limit as h approaches 0. And it's the limit of what? Well, if we look at these 2 terms, we can see that both of them, they actually do have something in common, and that is h, all right? So we can take h out as the highest common factor. And when we do, we are left with 2 into x minus 3 from the first term, and we are left with h from the second one. But then we say everything is divided by what? By h into square root x plus h minus 3, which is all squared. And this is added to x minus 3. which is further squared. So now we have achieved our aim, things that will commit suicide. And after they cancel out, we are now left with the limit of this expression, and we can now use direct substitution. So the h will die. In the numerator, we are left with 2 into x minus 3, which you can choose to distribute. There is no problem about that. And then if you go to your denominator here, then what is going to happen? Well, if you go to your denominator and let h to be 0, then you now have the square root of x minus 3 squared. And this is added to the square root of x minus 3, and it is squared as well. Then adding the two like terms in your denominator, well, you'll see that it's supposed to be 2 times the square root of x minus 3 squared. All right. But then, of course, the 2's will cancel out, right? Because you're supposed to have a 2 there, and that 2, those 2's will cancel out. And when they do, in the numerator, we are left with x minus 3. And in the denominator, we have the square root of x minus 3 squared. But now, since we know and understand that every time we see square root x, we see absolute x. And this stands to reason that every time we see the square root of x minus 3 squared, we actually see absolute x minus 3. And these two are completely different things, so there is no need for you to try and simplify, but it's perfectly fine if you leave it exactly as it is, like that. Anyway, you can't simplify this because you don't know what is the sign of absolute x, right? So you can't do anything further to that. But of course, we know that if maybe we are coming from the left or from the right, you'll replace the sign accordingly. But it's not necessary. You are finding the derivative at any point. So this is your derivative of the function. I think the most important thing was, how do you get out of this mess? Which mess? This one. How do you escape that?